Hello everyone. Today in this video we are going to see the concept of FDDI. FDDI stands for Fiber Distributed Data Interface. It is a set of ANSI and ISO standards for transmission of data in local area network. FDDI is a networking standard developed in 1980s by ANSI. It was designed for high-speed data transmission using fiber optic cables, making it one of the earliest standards for high-throughput local area networks. FDDI addressed the limitations of Ethernet at the time by offering greater speed and longer transmission distance. It uses optical fiber as its physical medium. FDDI gives 100 Mbps of information throughput. It incorporates in two interfaces. FDDI convention is based on the two-token ring. Next we'll see some key features of FDDI. Speed. It is operated at 100 Mbps, which was significantly faster than the 10 Mbps standard Ethernet. At the time, this enabled applications requiring rapid data transfers such as large file transfers and high demand computing. Topology. It uses a dual ring topology. Two rings ran in opposite directions. Primary ring which carries the data and a secondary ring which acts as a backup in case of failure. Medium. It is primarily uses fiber optic cables which allowed for longer distance and less electromagnetic interference. FDDI2 supported copper cabling though with some trade-offs in performance and distance. Capacity. It supports up to 500 stations connected across a 200 km distance. This made FDDI ideal for large campuses and distributed enterprise environments. Next we'll see the architecture of FDDI. FDDI consists of two components, that is dual ring design and token passing. A dual ring design contains two token rings which are known as a primary ring and a secondary ring. A primary ring is used for data and token transmission and a secondary ring that provides backup if the primary ring fails. Token passing. It uses a token passing protocol for media access. A token, which is a small control frame, circulates around the frame. It is a device must capture the token to transmit data, ensuring orderly and collision-free communication. Next we'll see how the FDDI works. Token passing, which means the circulation of token. Token travels on the primary ring and a node that wants to send data waits for the token. Primary ring, it carries out some normal data traffic. It functions as the main communication channel. Secondary ring, it serves as a backup in case the primary ring fails. It can also be configured for load balancing, increasing throughput. Next we'll see about FDDI frame format. FDDI frame format detects data packet structure. It has specific structure to ensure reliability, such as preamble, start delimiter, frame control, addressing fields, data field, checksum. Here you can see the diagram of the FDDI. First is preamble, which is of 1 byte. It is used for synchronization. And second is start delimiter, which is of 1 byte that marks the beginning of the frame. Third is frame control, which is of 1 byte that specifies whether this is a data frame or a control frame. Fourth, destination address, which is of 2 to 6 bytes that specifies address of destination station. Fifth, source address, It is of 2 to 6 bytes that specifies the address of source station. 6. Payload. It is a variable length field that carries the data from the network layer. 7th is checksum. It is a 4 bytes frame check sequence for error detection. And the last one is end delimiter, which is of 1 byte that marks the end of the frame. Next, we'll see some applications of FDDI. First, backbone networks. Backbone networks used as a core network to link smaller LANs, high-speed LANs. It is suitable for demanding environments needing high data throughput. Campus networks. These are connected multiple buildings over long distance. It is used for connecting multiple buildings over a long distance. Industrial system. It deploys in manufacturing plants and control systems where reliability and speed were crucial. Next, we'll see some advantages of FDDI. High reliability. The dual ring structure ensured continuous operation even if one ring failed. Long distance coverage. Fiber optics allowed connection up to 200 km, far beyond the capability of Ethernet at the time. Deterministic access. Token passing ensured predictable and scheduled access to the network, unlike collision based systems. Redundancy. The backup ring provided automatic failover capabilities. The limitations of FDDI. It is costly as fiber optic and associated hardware were expensive. Ethernet eventually became more cost effective. It has complex setup which requires specialized knowledge for installation and maintenance. It is obsolete, which eventually replaced by faster, cheaper technologies like Gigabit Ethernet. So, the conclusion of the topic is it provides a historical role. FDDI was a pioneer in high speed networking and influenced future designs. It, it has legacy technology, though no longer widely used. Its principles laid the groundwork for modern networking. It used in network evolution. Understanding FDDI helps in grasping the evolution of LAN technologies, including concepts like redundancy, deterministic access, and fiber optic transmission. Thank you.